All right. I wanted to look at an application of systems of linear equations, and a common one is in business when you're trying to determine what's called a break-even point. When you're manufacturing something, you're going to have costs incurred when you're making them, and then you're going to have money that you bring in that you get when you sell them. And so a lot of times we're very interested in this. How many radios must be produced and sold for the company to break even, which means to just recoup their costs. And, on this problem, we really can see from the graph where that happens. That's one example of what the point of intersection is good for. So that point of intersection tells us that if you make 500 radios, okay, you're going to bring in $25,000, and that if you make 500 radios, it's going to cost you $25,000 to do that. But see how it's where the two intersect? That's the break-even point. So the answer to 55 is really 500. Okay, so what we've got are these two equations, and they are using a notation that we'll talk more about called function notation. You can kind of just think about both of these just being a y to make it fit with what we've done before. So we're looking for where does the equation representing the cost, where does the cost equal the revenue? And so what we will do is think about it like this. So we have 10,000 plus 30x was my cost, and 50x was my revenue. Okay, but the R of x and the C of x, that's like your y, that's like your dollars, right? So we're looking for where those are equal. So we could use substitution. So I just want you to kind of have a sense of why do we learn about systems of equations? Here's one example of why. A lot of times we're interested in where the break-even point would be. Okay, so now we'll finish by solving for x. So we wind up with 20x equaling 10,000. Dividing by 20 tells us what we could tell from the graph, okay, that we wind up getting 500 radios. So to just break even, you would need to produce and sell 500 radios. If you want to make a profit, you need to do more than 500, make more than 500 radios, okay? Okay. All right, now, there's a question I thought would be worth looking at down here. I just wanted to look at another one. Let's look at one, maybe like 61. Okay, a company that manufactures small canoes has a fixed cost of $18,000. That usually covers things like the warehouse in which they make the canoes, maybe the insurance, the light bill. Okay, and then it says it costs $20 to produce each canoe. So it has a fixed cost, and then this other one is sometimes called the variable cost. That covers things like the materials for making a canoe, okay, or the extra employees you might need, that type of thing, okay? So that first sentence involves the cost, okay? So the cost is going to wind up equaling 18,000, that's fixed, okay? But then plus $20 for each canoe. So if we let X represent the number of canoes produced and sold, that would be the equation that represents the cost of building the canoes. Okay, and then it says the selling price is $80 per canoe. So that means if I sell one canoe, $80 would be how much I'd bring in. Two canoes would be $160. So the revenue would equal 80x. And then the break-even point is where I'm looking for break-even. That's where the cost equals the revenue. So I'm going to set those equal to one another. And then we're back to that example from before. So I could take away 20x, and I'd get 60x equals 18,000. and I need to divide by 60. So that's going to knock off 0. 6 will go in there. Looks like 300 times. So I'd need to make and sell 300 canoes to break even. And so I'd want to, my goal, of course, would be to make money. So I'd want to sell more than 300 canoes to make some profit. Right? So cost and revenue is one example. Supply and demand, that's another business example. Here's another example I'm just going to talk about. You might have, like, say you're trying to determine where you want to have a wedding. Well, one company might charge a flat fee. Maybe they charge $1,000 and then $20 per person. So that's from one company. That would be the cost of the reception. And then the other company might just charge you a whole lot less here, but maybe charge you more per person there. Okay. And you're trying to compare and decide which company to go with. So points of intersection can help you with that decision, because one of these will be a line that's rising. Maybe it starts at 500 and looks like that. And then the other one would be a little flatter, but have an initial fee of 1,000. And that point of intersection would give you information you need, because that's where the two have the same cost. And then see, when you're over here, this one's the most expensive, but when you're over here, this one is. So if you're basing your decision on cost, you'd want to use this guy when you're less than whatever that turns out to be, and this guy if you plan to have more than that number of people. But if you're having a small wedding, you'd want to go with the company that charges less initially. If you have a big wedding, you might want to choose the one that charges less per person. So just want to give you a sense that systems of equations, they're pretty important to know how to deal with. And we just reviewed solving 2x2 systems in the previous video. And then I just wanted to do a little application where you could see its use. Okay.